quite like I do on you.
Hi, ladies and gentlemen. A very good evening to you guys. Welcome to SGInnovate. Thank you for coming down this evening. It's great to see such a great crowd here today. So I'm Nikki, community builder at SGInnovate, and today will actually be my last event at SGInnovate as I am heading back to school. So I am super glad to end it on such a great note with such a great event. And at SGInnovate, we focus a lot on deep tech, actually solely on deep tech. And what we do is we strive to be the deep tech innovation hub for Singapore and hopefully and subsequently for the rest of the world. So we don't just focus on deep tech like AI, blockchain, or medtech, but what we want to do is to see how deep tech can actually cut across different industries and impact and solve world problems. So for today's event, definitely it's on blockchain, on energy, and we're co-organizing it with Enrupt, who is a very important partner with us, who they're doing super amazing things with us in this deep tech space. So without further ado, I'll hand over the time to Katarina. But before that, I would just like to give a big thank you to the SGInnovate community here for being such a wonderful community, and I had a super good 8 months with all of you. So without further ado, Katarina, please.
And we are hiring, so if you finish and you want to work in energy, maybe you can come and work with us. Last year, 120 startups raised more than 320 million dollars across the world for applications of blockchain in energy. And blockchain, some of you might know, is a technology that allows for decentralized storage to record transaction data. And I think some of the speakers will go into the details of what blockchain really is and how it is used. It's actually a solution that is cheap, somewhat secure, and it can be deployed very fast, and that's why we like it in energy. It allows us to decrease costs of transactions, it allows us to increase the speed of deployment, and it allows us to do transactions that would normally not be possible. And if some of you are still thinking, what is she talking about? I'll give you a few examples. For example, for electricity networks, blockchain allows us to do wholesale electricity distribution. It is an underlying technology that will allow us to do peer-to-peer trading of electricity or electricity data management. In oil and gas, it's already piloted for use in gas or commodity trading, for supply and data management. So this is great, but the problem for now is how quickly we will be able to build blockchain solutions and how can we scale it across an industry that is huge. Energy industry represents $2 trillion of investment per year. So if you imagine that, if you imagine that sort of money going into these new type of solutions like blockchain and AI, it's artificial intelligence, it's really a fantastic economic opportunity that lies ahead of us. But the title of today's session is Blockchain in Energy, Dream or Reality. So we are going to try to test what is possible today, what will be possible maybe 5 years from now. I will be the moderator. My name is Katarina Uherova Hasbani. I'm founder of Enrupt. Enrupt is an open innovation company for energy sector. Our vision, as you can see on our banner, is to build energy company of the future. And we believe it will be built with clean, decentralized, and digital technologies. And we do that by creating a bridge between startup innovations and corporations. And talks such as today's, we have them monthly in Singapore. So if you are interested in teaming up or you have an idea for a talk, please come to me. I'm always happy to partner or to take your idea to build a panel around it. Today I won't be alone. We have 3 fantastic speakers lined up. I'll shortly introduce them. They will make each of them 5-minute presentation about their project or a startup, and then I have for them few questions and we will turn over to the Q&A. We should finish by around 8:30 to leave some time for networking. So let me just speak briefly about each of the speakers, and then I'll ask them one by one to come and make their presentation. So first speaker will be Nicolas Payen, who is the co-founder of Positive Energy. And Positive Energy is using blockchain to connect investors with renewable energy projects. Then Pernille Dahlgaard will speak. She's director for infrastructure in Accenture Singapore, and she will be exploring how blockchain is used in shipping. Shipping is very important, especially for transport of commodities that we use to produce steel, roughly 80% of the global energy mix. And finally, the last speaker, but not the least important, is Martin Lim from Electrify. And Electrify is quite a pioneering startup in Singapore because they use blockchain to build retail electricity marketplace in newly liberalized electricity market in Singapore. So thank you for taking time today. And now I will hand it over to you. Nicolas, would you like to start with a short presentation? And then we'll follow it with a panel.
Okay. Thank you, Katarina. I'm very glad to be here this evening and have the chance to share with you what I'm doing. So at Positive Energy, we want to simplify renewable energy finance. Why do we think it's important? It's because in the next years to come, there is a need for a massive investment in power generation in Asia. We are talking $5.5 trillion of investment. And in fact, most of this investment is going towards renewable energy. Or why people are choosing renewable energy. There is some obvious environmental aspects, but the most important is people now are choosing renewable energy for economical reason, because it's the cheapest source of energy available now. So you see over the years, the solar energy and the wind energy price has been falling down. And last year, in India, 2 projects has been awarded the lowest price of electricity ever, and they were solar projects. So people are moving to renewable solar and wind. But at the same time, people are moving to solar and wind, the typology of project is changing. You are moving from big centralized assets to a multitude of small decentralized assets. That means that people invest in their own generation for their own building or plant, in order to get energy at lower cost and with a higher security of supply. The problem is that the system that exists today to finance the project is used to work with very big projects. And when they face small projects, they have a hard time to work for and finance this project. The reason why is because if you want to invest 5 million or 200 million, you will pretty much do the same work. You will go through a due diligence process, and this due diligence process takes time and is complex and it's costly. So it's a problem for both the developer and the investors, because there is this big part of the market that requires funding and that is difficult to solve. So that's the problem we want to solve. Today, people are working in a very old-fashioned way. They use email, Excel file, and we believe technology can improve. So our solution is in fact a digital platform. Our digital platform is a marketplace. People can come and list their project and their asset, and investor can browse and select the asset or project they are interested in. What we do in order to cut the transaction cost is that we have a tool that helps the due diligence process. And this tool uses blockchain to record all the exchange of document and information between the seller and the buyer. And that's how we help the transaction to take place. So our goal is to become the leading platform for sustainable infrastructure investment and trading. We start in Asia with solar asset mainly, and we plan to expand over time with other assets like wind, biomass, EV charging infrastructure, energy storage, and also other geographies. We do that because we believe there is a big market opportunities, but we also think by doing that we'll help societies. First, accelerate the adoption of renewable energy with good to reduce the carbon emission. Second, we would like to help local investors to be part of these business opportunities. Traditionally, you need domain expertise to do such kind of investment. With our platform, we can make it easier for the investor to invest. Finally, a lot of the local developers don't have access to capital, so they cannot develop and become successful entrepreneurs. We believe our platform will help a lot of local companies to compete more effectively and to grow in successful companies. This last slide is to prepare a bit the discussion we have tonight, and I try to give a rough overview of how I see the usage of blockchain in the energy sectors. There is, for me, three main applications. There is a security token, where people use blockchain in order to create value at the asset level. They are asset-centric. You invest in an asset through the blockchain. There is a utility token, where people use the blockchain to deliver an invoice for a service. And finally, there is the distributed ledger. That's the use of blockchain in order to improve, automate some existing process or new processes that are required in the industry. We clearly play on the right side. We have decided to intentionally to play there. And we see a big adoption. You don't really see it. It's behind the panel. But there is player in all these three dimensions. And I will say they have different stage of adoption, and I think that's what we are going to discuss later. Thank you.
Thank you. My name is Pernille. I'm working at Accenture, as Katarina mentioned. That just happened magically. That's the beauty of technology. How many of you had heard about blockchain 2 years ago? Wow. This is a specialized group. I heard about it 2.5 years ago, and I have to say, I did not understand a single thing of what the lady was telling me. She was saying something about blocks and changed and sharing, and what the world is that? I have a really good colleague, and he's a specialist in blockchain. So he said, Pernille, it's just like a WhatsApp group, nothing more. And I think that's actually quite a good description. Of course, it comes with a little bit more security. Of course, it comes with a little bit more, say, sophistication maybe than WhatsApp. But the whole thinking of saying that it's a way where you can share data, you can share information within a group, that's actually a good analogy. So, as Katarina said, I'm from infrastructure and talking about shipping and stuff like that, but that's kind of pretty linked to energy when it comes to it. And if we look at most companies, and this is specifically then from a shipping context, the ecosystem we have is super, super complex. We have a ton of actors. They don't know each other. They are sitting in different parts of the world. They don't trust each other. And they do one-to-one transactions. So that's what we have tried to illustrate here, that sellers relate to a firm that relates to a broker, etc. And when you're, for instance, sending goods around the world, you will need some 20, 30 documents in order to send something from Chicago to Melbourne. 70% of the information that you have on these documents is exactly the same. But because of that structure, you need to replicate it, and you get a lot of work, and a lot of duplications, and a lot of errors. So it's super time-consuming, and quality is not great. The blockchain, and I mean, congratulations, Katarina. It's a beautiful banner. And it's completely new because Katarina... Exactly. No, I know. And Katarina has been so busy that she broke her banner. It has been worn out, and this one is a new one. That's excellent. And it doesn't matter because the slide is actually fine. But what you see up here is the connectivity. as Nicolas said, it's a platform where you can just share information. It's simple, it's real-time updated, and all the stakeholders has access to all the data. So it's rather simple. Now, again, shipping is just such a great, and logistics altogether is such a great use case for blockchain, and that's why I want to dwell a little bit on who are all the actors. Because again, where blockchain comes in as a fantastic, promising technology is where you have a lot of parties and you don't have connections, you don't have trust. You can create this immutable tool where you can exchange information. This is an extract of all the actors that are involved in a shipping transaction. This is based on a tanker ship. And the opportunities is immense. All these people are communicating to some extent with the shipping company and maybe with each other. If we look at what are the usabilities in shipping for blockchain, we have a few, and I think actually I was very glad when I saw your slide, Nicolas, your last slide, because that I think goes nicely together with this one. We have three main groups where we see in shipping logistics usability, and the first one is in terms of efficiencies. Processes, what I just talked about, documentation being simplified, you can eliminate a ton of jobs, you can make people do much more exciting stuff. So that's one area. The other area is to improve the supply chain transparency. I don't know whether you're aware, but 40% of the wine that is being bought by users in China for $40 or more is counterfeit. That's of course not deadly or lethal or anything, but if it comes to pharmaceuticals, it becomes more of a problem. There's 1 million people who is dying every year from counterfeit medicine. With blockchain, you can authenticate whatever you're buying. You can ensure that it has not been frauded or anything. So that's an immense opportunity. And you can of course also trace where you have your goods. And then the last option and use case we see is what is called smart contracts, and I'm sure that who of you do not know what a smart contract is? Oh, thank you, because otherwise I would stop talking. But I can explain it to you. Basically, it is the concept of having some predefined prerequisites defined before you go into any kind of transaction, and then when these prerequisites have been fulfilled, you will have an automatic transaction. In shipping, you have a very long delay, often from payments to be executed. If you have these predefined criteria, automatically, as soon as everything is settled, the payment will be, or the transaction will be executed. So a lot of great use cases, a lot of great opportunities. We can save tons of boring work. We can reinvent the way we are interacting, and we can hope that it's implementable at some point in time. So based on that, I'll pass on to you, Martin.
Thank you very much. So I think everyone's already said what I needed to say, so not much of an introduction. So that's my company, Electrify, right? My name is Martin Lim. I'm the CEO of Electrify and one of the co-founders. So the thing here is, I'm glad everyone's really blockchain aware. But one thing I need to say is this, right? For as much as we, the people who want to promote blockchain and everything else are out there saying it's going to save the world and all that, we have to be very, very aware that the blockchain isn't a magic condiment. It's not something we sprinkle on stuff and blam, it gets better. It's magic, right? It doesn't work that way. Technology is still very nascent. We're very early days, very early stages of development and so on, right? And we're beginning to find out where the walls are, right? Blockchain is really, really great when we look at moving values, moving ideas, locking concepts, storing them, transferring them, and sharing them. It's really great for all these things. But like, to use logistics as an example, blockchain is really great for tracking, right? Showing provenance, making sure all the processes are in place and all that. But blockchain's not going to replace the ship or the car or the road. That still has to be there. And that's relevant because in the energy space, And we get asked this quite a lot. We get asked, people ask us, say, when's Electrify going to disrupt the grid? When's Electrify going to change things up? And I always got to put brakes on that and say, it takes a while. It takes a heck of a long while. Grids, power grids on a citywide scale, where our business, our project is operating, power grids on this scale is in the order of hundreds of billions in asset value, built over decades by the sheer will, mandate, and order of governments. So it takes a while to change. So what exactly does Electrify do within this space itself, if I'm saying it's so difficult to change? We started the business a year and a half ago as the first retail electricity marketplace in Singapore. And we felt we needed to do it because there was a need for such a product, such a service within this market itself. And there was no blockchain in it. We just did it. And what we did at first was we actually started by digitizing electricity contracts and putting it onto a digital platform. And that's it. Prior to us coming to the market, everybody went by with pen and paper, signing contracts, collecting checks, and so on. The fastest deal that could be done to close a contract was maybe a week. Now we regularly close contracts on our platform in under 10 minutes. So that's what we did. And that's the first D in among 5 Ds in blockchain, which is digitization. So we did that. We made some money very quickly. We went to market and so on. And we started looking for efficiencies within the system. And that's when we looked into blockchain as a solution to be able to execute these same digital contracts as smart contracts. It was a very, very simple concept. Could we bring all these electricity contracts for contracting, especially now we're going to the final phase of deregulation in Singapore, we're going to OEM, the open electricity market, starts on November 1st. So remember electrify.sg, guys, November 1st, right? So we take these electricity contracts and move them to smart contracts. Could save a great deal on the cost to serve each and every one of these contracts. You wouldn't need the servicing, the finance teams or the lawyers and so on and so forth to follow up all these contracts. But on the back of that research, you realized you could deal with another elephant in the room, and the elephant was this. We start looking into the ability to trade power. We start researching into that. Why was that relevant? Because the energy space, as we know it, is changing, it's evolving very, very quickly, right? With easy access to materials, technology, knowledge, you could get onto Taobao, for example, right? And buy yourself a solar panel kit. Install it yourself if you've got the guts to climb on your roof and do it. Or call a contractor to put it up for you and pay for it and research the whole process. Everything's online. The access to information and raw materials is changing the space. The proliferation of distributed energy resources, DERs, is going to, over time, change the energy landscape. So the elephant in the room really was this. What are we going to do in that kind of a space? When we looked into it, we realized a lot of energy startups talking about peer-to-peer, we're dealing with it on a microgrid level. So microgrid's easy. It's like maybe the first 2 rows of us, we all live on the same street, and we run our cables between each other and we trade power. You make some, I'll buy some, and we measure the settlement between us. Easy. But how do we scale it up across a neighborhood? How do we scale it up across a whole precinct? Or in our case, what we were planning for, we wanted to scale it up across an entire city. So what we developed was a platform called Synergy. And using the abilities of what can be done on blockchain, this is how we're executing it. This platform to trade power is going to deploy. The alpha goes out in the next couple of weeks. What we imagine is a user interface similar to this, where the end user could actually see the sources of energy, see which percentage comes from where. Where it's from the main grid itself. Is there a laser pointer? Yes, there should be one. Oh, well, there isn't. Right? Where it comes from solar, they could pick which provider of energy they want to buy power from, and understand a little bit more about this energy. And of course, this is what we dub the energy sleeve, the components which this renewable part does not fulfill. For instance, you want to buy solar, you get it when the sun shines, right? Once the sun goes down, you're not going to have any power anymore. So someone's got to fulfill that component. That comes from a traditional retailer, a business which we are very, very familiar with already. So this is one thing we imagine. Towards that end, we've built our own IoT device. We built our own power pod. This device pulls various inputs of different kinds of data, whatever we want to plug into it. In our current office right now, this morning we hosted an accelerator by our office, and we showed them we had a temperature and humidity sensor stuck to the window, pulling data of that, feeding to this box. They were streaming the data back to our own servers over practically any protocol you want, 3G, 4G, you want to put it over Wi-Fi, LAN, you name it. It can be configured to even work on an RF mesh. So that's what we built. And this is the kind of data we're pulling already. We ran this as our MVP. We're running this for the last few months, and now we're confidently moving to alpha. We're pulling the data from production to consumption and mapping that against wholesale energy prices. So here's the magic sauce. The magic sauce really is how the heck do you trade power across a main grid itself? How do you move these electrons? And the trick here is this. Most lay people don't understand the fact that you don't need to move the electrons. That's not the concern. We've known how to move electricity, move electrons for decades. That's not a secret, right? It's more complex than primary school science with a battery and a light bulb and some wires, right? But we know how to move electrons. The problem is, how do we settle? How do I tell how much you've produced versus how much you've consumed? That's always the problem, the settlement. So the mechanism we use for settlement is a mechanism called a contract for difference, a CFD. That's mapped against the wholesale prices. So data like this, right? The settlement occurs on 2 layers. It's tracked through this kind of a dashboard, which goes into our peer-to-peer trading engine. And here's the trick. When you've got a producer and a consumer in an ideal world, 100% of what you produce is consumed by you, right? Everything he produces equals to everything you consume. But that's the ideal world, and it never happens, because some days sun's a lot brighter, you produce a lot more, but he can't consume it. What happens to that surplus? Some days, if it's raining, but he's throwing a party, he needs a lot more energy, you can't fulfill. So the key really is, again, in matching. So what we do is to take these 2 sets of data, we built a matching algorithm which goes into this. We have an optimum supply and demand platform that we call Synergy. Like I said, this is real. We're building it and we're going to alpha in the next couple of weeks. Really exciting. So this stuff is not due for a public announcement for the next couple of weeks, but we just came back from Tokyo just this morning, and we've got a signed agreement with TEPCO that's investing into our business. TEPCO is the 4th largest power company in the world, largest player in Japan, and what we're looking to do is actually, after we finish our alpha, we're looking at scoping and deploying an alpha test in Japan itself for Synergy. And lots of market and commercial reasons for this, and TEPCO's taken a strong interest in this. So we're hoping if this all works out, we can smell commercialization in 2020. At the same time, commercialization in Japan in 2020, right? At the same time, we're also working out a research piece with Take Energy. They operate in Kyushu. They own 6 solar farms, and they own a retailer called Kumamoto that operates out of Kyushu as well, executing similar to be able to track the transfer and sale of that energy from their solar farms to their retail customers. So that's what we're doing, and that's what we're doing on blockchain. And this is also interesting. So we've got an MOU signed with Narada. We're looking to explore projects with them. One of the key projects really is this. In a lot of the calculations that we've done, we've left out battery storage systems because on a grid level, it just doesn't work. Everyone talks about it, but it's not there yet. However, these guys, they're the 2nd largest battery company in the world, second to guys like LG Chem and Samsung. These guys sit on gigawatts worth of energy across power grids around the world. And the thing here is this, battery management systems, by and large, are inward-looking. They look at the needs within a facility itself and how to maintain the life of the battery. What they don't do is take in market signals. But because of our Synergy platform, we operate with market signals. So imagine this, in the Singapore market, for example, we operate on a 30-minute market. That's 48 periods a day, within 24 hours. Other markets, like Australia, is moving into is 5-minute markets. What that means here is this, at a point in time, at a period, there's a price spike, we can inform their systems to discharge and sell power to the grid. That's an arbitrage opportunity. And when prices stabilize again, they top up the batteries again. And because batteries aren't like generators, they don't have to spin up. They literally can discharge within that same period on activation. So that's what the technology can do, right? And that's Electrify. Thank you.
It's okay. We are very diverse panel, by the way. Very balanced panel, right? Fantastic. This was super interesting. Now, we'll step back a bit because, okay, there are many people here who are interested in blockchain, and I wanted to ask each of you, Pernille, you already mentioned it a bit, but how did you start with blockchain, right? How did you get interested, and just a little bit about your personal story so people can get inspired for some ideas how they could go about it.
Okay. I think I always have been interested by emerging technology. So I worked for many years on Internet of Things, and I did a lot of work there. And I keep hearing about blockchain, and I was a bit like you know, what is that? And of course, when I start to look into blockchain, the first thing I came across was cryptocurrency. So I started to look at cryptocurrency and the concept associated to it. And then digging into the technology, I become very interested by the underlying technology that enable cryptocurrency. And very quickly I say, okay, what can I do with it in the industrial world? What are the applications in the enterprise? Because I always spend my career in industrial company, in B2B interaction. And I became fascinated by the potential use case associated to it. And so when naturally I say, okay, let's start a startup, and I wanted to do something around energy, renewable energy with tech, I say, what can I do with blockchain? And that's how I started.
There we go. Well, I'm working for Accenture, and we are a technology company, but we're also a digital company. And we have 460,000 people globally. So a lot of people, it's a bit different from my colleagues here in the startup business, meaning that we have a lot of people who are investigating what is the newest, what is on the forefront, and hence something like blockchain is catching our attention. As I said before, it didn't make any sense to me in the beginning. But what I figured out, especially actually after coming out to Singapore a bit more than a year ago, is that a lot of super cool people find blockchain interesting. And I don't know whether it's a bit of a conundrum or whether it is just that super cool people often find new things interesting. So I figured out that if I got involved in this, I would have the chance to talk to a lot of cool people. So here I am.
Great. I like that.
Okay, so our story was...
Are you cool?
No, hell no.
Very cool.
That's my mother.
That's not cool. Nah. Our story really very simple. We launched the business. We took it to market by July last year. We launched it in July. Within 3 months, we kind of broke even operationally. We worked really hard, very lean operation and so on, right? And then we hit a wall. We couldn't make more money. We couldn't get more commissions. We couldn't get, we want to figure out how. And at the same time, we did a research piece with Accenture. We actually worked with 2 guys from your team. We spent 2 days with Accenture. We went through exploring all the different energy markets that were liberalized around the world and what a marketplace and its relevance in these areas, right? And what's sad, was absolutely dismal, was pathetic, right? The outcome was the understanding that as Electrify, we're doomed. Unless we diversified our portfolio and sold other things like mortgages, insurance, credit card plans, all the wonderful stuff, right? Because the margins just weren't there in energy at retail, right? So we went back, we talked about it, and it was a tough time because we thought, holy crap, that's it. We just started the business, we're gonna die. And we said, no, there's got to be some other way. So we went to look for efficiencies in the system. We couldn't get people to pay us more, so we figured, what if we could help them save more? So we started researching and find different ways of doing it. We already brought digitization to the industry. So the next thing we did was, could we improve on digitization? And that's when we started learning about blockchain, and we spent a lot of time researching, understanding what it could do, and that's how we got into it. We felt we had a use case, and we wanted to develop a solution based on the use case we had. So yeah.
You've mentioned something interesting in your presentation. You started talking about commercialization of some of your projects, and you mentioned 2020. I want to talk a bit about timelines. What is really possible today for usage of blockchain? Are we really talking just about some piloting opportunities? Are these really serious commercial projects? How do you see the timeline for deployment of blockchain?
I think that's a tough
scale,
one.
yeah.
At scale, that's a really tough one. I think it depends on the industry, right? So for instance, if you are building a blockchain project about decentralized storage of personal information, right, sovereignty of data, for example, you could build it and deploy it and wait for people to come. And you could scale the business up that way, right? There are really no real rules, laws, regulations stopping you from deploying. You could go worldwide tomorrow if you wanted it to. With energy, it's very much different. We have to play within the rules and the boundaries within every market we go to. We develop this algorithm, but that's compliant to all the sums and calculations and numbers and performance of this market. So when we look at moving this to Japan, some of the math has got to change. We reckon as much as we can, well, it probably won't change horribly, but a lot of that will have to change because every market has its own rules, right? One very simple example, in Singapore, our market is structured in such a way where 100% of all the energy we consume, all that's produced from the 7 generation companies, there are only 7 gencos in Singapore, right? All 7, whatever power they produce, 100% of that energy gets transacted through the wholesale market, the EMC, the energy market company, which incidentally is owned by the SGX, right? Out of Japan, for example, is a whole different market structure. They deregulated about 3+ years ago, right? And in their market, something like, if I remember correctly, something like 5% of the energy gets transacted through the wholesale market. So where's the other 90+%? All off-market deals. So you can imagine it, right? The likes of like the Toyotas and the Mitsubishis will go straight to the TEPCos and say, hey, I've got so many factories around on your grid. I want so much power, you're going to cut me a deal. It's a direct off-take agreement. So that doesn't get transacted on the wholesale market itself. So the structures are different. So these are one.
So you cannot directly scale.
No.
Every time, in a way, you have to develop a new product,
in
basically.
every single country that we go to.
Yeah, and that's common not only for blockchain, for any type of, I think, digital technology. That's the main limitation for the energy sector is the regulation,
Exactly.
and is the fact that we haven't yet, but that's a different discussion, which maybe we'll have in one of the next talks. How do we scale, or how do we systematize liberalization of electricity markets? Because we've done it in US, we've done it in Europe, we are now doing it in Asia, and we still don't have a good formula for it. So, Pernille, what about shipping? What are some of the, how do you see the deployment over the coming 2 to 5 years, and where are some of the barriers?
I think the biggest barrier is the technology. As I was saying, it's a super promising technology. Yet, if you're looking at computing power, if you're thinking of putting, say, all the containers that are being shipped around the world, which is 90% of all the goods that you're getting is being seaborne. If you think of getting all that on a platform, you want to have pretty fast transactions, and blockchain can nowadays provide 7 transactions per second. That's going to be a very, very long booking process. So until the computing power that's supporting this kind of platform can rely on quantum computing, I don't think that we're going to see we will see a lot of pilots, we will see a lot of proof of concepts, people will learn a lot, but I think there's also a bit of an optimism in terms of how quickly is this actually going to happen. My personal optimistic guess is that 5 to 10 years from now, there'll start to be sort of really value behind blockchain-powered
Are there pilot projects already among the shipping companies or energy companies that use shipping?
Absolutely. Container shipping is probably where there's most pilots going on. There's a big workload and big challenge in all the people who are doing documentation. So some of the biggest container shipping companies are doing consortiums together with IBM, together with Accenture, of various level of sophistication, of various level of, say, transforming the way we're doing business. Some of these consortia are making a lot of noise about what they're doing. A lot of the consortias make it sound like, you know, in a few weeks we're going to launch and it's going to go public. So I think when you're reading in the media, you get the impression that blockchain is so much more here than in reality it is. And that is supporting the hype creation, where sometimes you need to take a step back and say, hey, this is probably a great learning, and I think it's needed in order for people to understand what are the potentials. But I got this idea this morning that it actually resembles a lot the dot-com wave we saw back in the 90s. Everybody were on the dot-com sort of wave. Nobody, I mean, you couldn't be taken serious if you were not doing dot-com, right? And then we had the crash in 99 or 2000. And it took a while before then. Everything that was thought back in the 90s is reality today. We do have e-commerce. I mean, everybody is using, well, maybe not everybody, but most people are using Amazon or using Lazada. We don't even think about how much we are using e-commerce. So all the thoughts that were happening back in the 90s, but I think we also need to recognize that new technology takes a long time to mature, and it is probably, we talked about it, there's a hype, you have to go all the way down, and then it will mature, and we will, 5-10 years from now, probably see the revolution starting.
So Nicolas, you go.
Can I just disagree with that for a second? I mean, I agree with the hype. Don't write the hype. Don't write the hype, right? But the technology, right? So here's the thing. We all know that Ethereum's got all these throughput limits, right? At best, 15 transactions a second, 15 TPS. But that's not the only blockchain. There are many other blockchain technologies. Never mind that Ethereum is trying to scale up.
Which one are you using?
So we're looking at deploying on a few different solutions, the hybrid solutions, right? So we're looking at exploring several different ones like Archain. Microsoft has got its own execution of Ethereum that sits on their own Azure servers, right? And that works on a whole different protocol, which allows you to have more speed and lower cost. Why Ethereum so slow? Because it's a proof of work. Lots of consensus, blah, 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 a lot of redundancy, therefore it's so expensive and so slow. But there are other protocols, right? Like the one that Microsoft is building is based on a proof of authority protocol, so you don't need as many nodes to validate.
Yeah. Maybe it also depends, I think, on the specific uses. So specific uses will be deployed faster than other ones, depending on the need for how many transactions per second you need to be encoding. Is that right? Yeah. Yeah.
Need scalability.
Yeah.
Yeah,
Okay.
and you're absolutely right. I'm focused on logistics, where you will have a need for a lot of transactions in a very short time. Where I'm
like energy as well.
Yeah. Yeah. Okay. So, Nicolas, you're connecting two industries, right? On one side energy, but the other side is fintech-ish.
Financial
how
world.
does it look there? Yeah.
Well, so I think the two sectors we approach are not the more innovative. They are forced to innovate, but they tend to be more conservative by natural behavior. So I think we have been also conservative in the way we use blockchain. So very quickly we decided to not do an ICO because I think most of our customers, the financial institution, the institutional investors, would not welcome us if we would do an ICO for governance reason or compliance reason. So we accept this limitation and we say, let's be customer focused and let's disregard this tract. We also decided to use a permission-based blockchain supported by an open project called Hyperledger Fabric, which is run by the Linux Foundation, backed up by IBM. So I would say IBM is one of the leading providers to the financial institution, who is also quite active in the energy sector. So we made rational choices in order to leverage the best possible ways of technology while fitting with our customer way of thinking. And so that's the work we do. How much can we push the edge to be innovative, to create values that has not been created so far, but not be off the field, you know, because you do too much. I'm very optimistic about the future of blockchain. When I think if
Short term or long term?
But long term, especially short term as well. I think if you look at Hyperledger Fabric, so this project supported by Linux Foundation and IBM, there is 400 pilots in the world deployed by IBM with enterprise customers. So here we are talking about MNC, multi-billion-dollar company, doing work with a prime technology provider to implement the technology and to modernize some of their key processes using this technology. This is not startup and student going out and playing with technology. This is serious people throwing out a lot of money in hope to do a lot more money. So that's why I'm very confident. And on the other side, I look at all the creativity and the radical innovation and the disruption that is coming from the startup world, from the, the cryptocurrency, the ICO. It's, I don't think I have seen that before, to be honest. Maybe, yes, the .com and the initial push towards the creation of the internet and the web application. But since then, I think there is nothing like it. So I think it's very difficult to imagine how it will impact the economy and the technology.
So is there some secret sauce in making a successful blockchain startup for energy? Because on one hand, it's true, energy sector is super slow. Even for Enrupt, we have a timeline of 5 to 10 years to do what we want to do because we move along with the sector that we serve, which is a slow-moving sector. The lead times are very long. I mean, anyone here who works in energy sector knows it takes you 12 months, right? 18 months to conclude a contract. And on the other hand, we have the barrier of human capital. At the end, we all still work with people, so it takes us time to get buy-in for these new technologies and so on. So what can we practically do to accelerate deployment? I mean, we talk a lot about acceleration, but sometimes for the purpose of accelerating the startups, but in energy, we need to get into the MNCs, you're right, because they are the ones who shape the energy sector. So, you know, how can we go faster with blockchain? What do you think? I mean, from the talking as a startup.
First, we are not a successful startup yet, so I will not. Don't take my word for granted. I can just explain how we think and why we believe we have a chance. So first, I've been 10 years in the energy sector, and I know the importance of regulation and the importance of the regulatory landscape and the fact that every market is different. And so first we pick an area where there is not much of this, or less. And that was a decision we took very early stage as well. And I hope it will help us to scale faster and to have less hurdle when we deploy the technology and we grow commercially. The second aspect is, yes, I believe we should engage with MNC, and we use a permission-based blockchain, and there is no blockchain of one node. That doesn't exist. Okay, so that's why if you go to the public blockchain, there is an infrastructure, a public infrastructure that do the transaction on the blockchain, and it's a public blockchain. If you use a private blockchain...
Can you maybe explain what is the difference between public and private? I'm not sure everyone understands, just to make sure we don't lose someone here.
Public and private. So public blockchain means the infrastructure that is used to execute the transaction is public, is available for everybody. So Ethereum is a public blockchain. That means everybody can develop code that will be run and execute by the Ethereum infrastructure. So then you have to compete to get access to the road, and you have to pay to access to the road, and that's why you have a transaction fee and gas. If you don't want to use a public infrastructure, people can decide to create their own private infrastructure. So I decided I will not use a public highway. I'm going to build my own road that I'm going to use especially for my application, and with the few people I have make an agreement with. So that difference between public and private. Private has a lot of advantage because you can scale it much faster. You can also tailor it to your application, that it really does the job well for what you want to do. But it doesn't really make sense to have a private blockchain only for you. Then you may be better not using blockchain, correct? So in order to use a private blockchain, you want to create some kind of consortium. So at one point, you have to federate people and manage this infrastructure with these people, or manage the infrastructure on behalf of these people. So the only way at one point to make your application or your technology successful and push a mass adoption is to be able to federate these people and create a consortium. So for us...
Wait, that's what IBM is doing with getting all these corporate
IBM
clients on their own solution.
Often what's happened, like you mentioned Shell and BP doing some work on trading. That's two people who come together. We say, we have the same needs, the same interest. Let's work together and let's create a common technology. So you have two. You can already share an infrastructure. So for us, the question is tomorrow, will we be able to do that, to federate a player and to create this consortium? If yes, then I think we will be part of this new generation of startups that build a decentralized world and is based on consortium. If not, then we will be like the Facebook maybe and the Amazon. That's mean company, very successful, but who manage as one entity the data, the technology, and in that way, I think you will lose part of the benefit or the value of the blockchain technology.
In a way, that's a very interesting point you're making, because in energy innovation, what we see a lot is this unilateralism, which I'm not sure it's so good. We can see a lot of corporate programs being launched. You know, I know just over the past 3 weeks plus next week, there have been like four different corporate programs that are running in parallel on energy innovation in Singapore. And I'm not so sure this is really conducive to helping startups at the end deploy their solutions. So good point, I like that. So are there any other ideas on how can we go a bit faster and make blockchain happen?
I don't know whether it's about going faster. I very much agree that...
Or better.
that the key to blockchain is collaboration, and it is a tool, and that's what we see in various industries, not only infrastructure and logistics, but for blockchain to take off, you need to get exactly a consortium together. I'm not sure whether that's making it fast, because having a consortium of, say, 6 people trying to agree on a governance structure, and it's somewhat new to everybody. Yet, I don't think there's any way around it, because exactly a blockchain, one of the prime benefits of blockchain is that you can share, and if you're only yourself, it's not so exciting to share, right? So I think that's really a key thing. And then I lost the second thought, which I thought was really smart, but anyway. No, the collaboration is really, really key. Oh yeah, and I think that's where blockchain is really a technology that fits, you could say, the trends in society and in innovation altogether. 10, 20 years ago, we talked a lot, and we had a lot of bilateral transactions between companies. Now we're talking so much more about ecosystem integration. There's a lot more awareness that without creating multiple partnerships, not only within your own industry, but across industries, into your, like, up and down your value stream, you're not going to be successful. And I think that's opening maybe it's actually a synergy, that you have the blockchain and you have this need for cross-industry, cross-value chain cooperation that will accelerate each other. And I think that's actually a really important aspect when you're talking blockchain.
Interesting. So Martin, do you think at the end it's something interesting that you said, that you've started with studying the options, and they told you, you know, you have to trade other things than energy in order to grow. So in a way, that's what Pernille is saying, right? She's saying that, okay, we can start with blockchain for energy, but Innovate will become part of this much bigger package of different things that will be trading, right? At the end, that's the advantage of blockchain is, you know, and for electricity, I mean, we are already using it to track not only the calorific, the energy value, but also the monetary value. So maybe it's like the first step towards a much bigger tool that will integrate energy and some other things. How do you see the growth for Electrify? Do you see it in energy or electricity specifically, or do you see it in other areas as well? If you are not, I mean, disclosing some well-kept secrets.
No, I think where Electrify sits, it's in our name, it's in our DNA. We're very much rooted in the energy space. But what's interesting about it is that where we sit, we're very much downstream. Right at the end, we're customer facing. But the kind of data we're aggregating, we're able to aggregate, able to look and measure at, has repercussions all the way up the value chain as well, which is very, very interesting. So just to give you one example. So in the course of running our MVPs, all the graphs that we show you, for example, we've been seeing some interesting load profiles, for instance. We're able, and we know some other companies in Singapore doing this as well, when they pull energy data. So here's the thing, right? That there's very little in big data and in AI that's not creepy. So this is creepy, right? By looking at your load profile, by seeing your energy consumption over 24 hours, I can tell what you've got at home. We can tell what device you have. If there's enough granularity, enough data to map that against, I can tell which model of which device that you've got from which brand. And that's scary as heck, because we can look at your load profile and don't even have to step into your home. We can look at your load profile and tell that your refrigerator is way too old, it's not efficient, is using 20% more power than it should. Therefore, hey, do you want to buy a new refrigerator? I'm working with Harvey Norman or Quartz, and they can sell you one on a good deal. So these are the repercussions. How this scales even further back up, you can imagine this energy profile that you have. One thing we describe as well, the ability to
personal profile, actually.
It's
not
profile.
Energy profile, it's a personal profile.
And
they also know when you are at home or not, so.
Yeah, that's kind of creepy. But more important than that is that you own the data. So what we imagine in the distance, and not too far distance, is that if you could own your own energy data, for instance, right, and we could allow smart contracts to carry out, for example, micro settlements of your bill. Imagine if you're able to have your power bill settled on a daily basis, handled by the blockchain. That's fantastic, because one of the big costs to your energy bill is a credit risk. If a retailer sells you a power contract, everybody that defaults at the end of the month, however small the default rate is, they don't lose money, you know. They pass that cost on back to you. But if they could do settlement on a daily basis, that's staggering, because that reduces default risk. And that means you could potentially get cheaper energy. And there are models to the other extreme. In Australia, for example, where smart meter penetration is less than 10%, right? There are models in Queensland, for example, where power bills get generated on a quarterly basis. Imagine you receive a bill every 3 months. You look at it and go, holy heck, I didn't spend this, I didn't use this, so you contest the bill. But what happens is the government comes back and says to retailer, you can't allow defaults to drag for more than a certain number of days. So you know what? Suck it up. Now, is a retailer going to lose money? They're not going to lose money. They pass the cost of that lost bill to the next contract cycle, and then next guy pays more. That's why power bills are so incredibly high. So if we can slice all that down to just micro billing on a per day basis, you literally pay as you use it. That's insane.
Utilities must love you, really, when you do.
It's incredible.
You are breaking down their margins completely.
It's fantastic, right?
For consumers, yeah. This is very interesting discussion, because it goes to the core of how do we integrate innovative technologies in energy, right? Because for now, and I've had this discussion with someone quite recently, it was about oil and gas companies capturing the value very early on in the production of energy, right? And they add this big fat layer on the top of what they produce, because they have to invest into big infrastructure, they have to transport it, they have to ship it to the customers and so on. So because we use 80% of the energy that we use is still oil, gas, and coal, right? So these companies, they get that. Now, the question with integration of all these new technologies is, how will this fat get redistributed? And it's not very clear, right? Are we going to take off the fat and electricity will be very cheap because we will produce it in a way from renewables, and we will use all these fascinating technologies. But anyway, that's just something I'm interested in. Now, how many questions are there already? Not only 2? 3? Should we start with the Q&A? Yeah, yeah. Let's take the questions from the audience. So please.
I've got 2 questions for Martin, if you may. For the first question is, how much of a cost saving, roughly as an estimate, did you manage to get when you first just digitalized simply, via the web? And then secondly, through blockchain technology, how much sort of, as an estimate, cost saving you had? And the second question is, on your algorithm to match users and all that, how easy is it in terms of some competitor to come out with a different algorithm and try and do what you do, sort of a Grab with Uber or something in your space, for example?
Okay, first things first, right? Savings, we moved from manual to digital. We didn't calculate that in terms of dollars. We calculated it in terms of speed, how fast it was to close a contract. So it shortened that time significantly. In terms of moving those execution of these smart contracts over to the blockchain, so in the Singapore context, the cost to serve every account at a household level is probably ranges about 5 to 7% of the bill that you're paying, right? Depends on your consumption, depends on the number of factors, but it's about 5 to 7%. In markets like Australia, it can go as high as 30%. So the ability to move the maintenance of these contracts, so what's the maintenance of a contract? Just because you and I sign a piece of paper, it's no guarantee that I'm going to behave myself or you'll behave yourself. No guarantee that you'll provide and I will pay, right? So you need all these other players to ensure we behave. You need your lawyers, you need your accounting team, you need someone to chase me, you need your customer service to call, hey, Martin, you haven't paid your bill, can you please settle, blah, 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 and so on. Then, of course, you have the cost of the credit extensions, the risk, the defaults, and all that stuff. So all these layer into the cost to serve this one contract. What happens then is if you run it as a smart contract, as they explained, a smart contract is a piece of code that executes the terms of a contract, a natural language contract, but does so automatically. It has no emotion, it's a piece of code. So you have an e-wallet, I have an e-wallet, conditions are met, end of month has arrived, I've consumed so much power from you, transferred. And that's what it does. So this cost to serve is reduced, drastically reduced, if not eliminated. And that's what we want to be able to derive. So these are the kind of savings. I'm sorry, the second question was? This way. Okay. Can someone else replicate and do what we do? Of course they can. Anybody can. You build an F1 car, I can build an F2 car, right? Anybody can. So like even as a marketplace, there are several competitors in the market right now. We're no longer the only one in Singapore, but we were the first. But looking at, and we do a lot of intel gathering, we do a lot of, we have a very active tech team. We do reckon that we still have a lot of technology that some of the others have not bothered doing it. They've treated it purely as a business. We address it as technology, whereby we build the underlying workhorses that can scale. And that's what we've done. We've done it from day one itself.
Hi, Pernille, Nicolas, and Martin. Thanks for the sharing. Thanks, Katarina, for moderating the session. So I have 2 questions. First, for Pernille. Like there are a lot of major players out there. IBM is working with Maersk in the supply chain shipping domain. There are other players not so big as them. What is Accenture doing and how is it doing things differently? And is Accenture willing to work with companies or universities in Singapore? And the reason I ask that is I come from a university academic background and I work on supply chain shipping problem that you described. And we're looking into blockchain as well, into how it can be integrated with the whole problem. So your take on how Accenture works and how it could work with people, companies and universities here. Second question for Katarina. Could you tell us more about Enrupt and how it actually goes on to build energy companies for the future? Because I'm sure there are a lot of people out there who would be willing to know that, including me. So thanks.
First of all, in Accenture, we are working with pretty much anybody we can find to work with. We are spending $2 billion a year acquiring startups and maybe more advanced than startups, but acquiring other companies. We are having collaborations with universities around the world. We are very much of a collaborative organization. We are not always easy to work with. We are not always fast, but we have good people, so that's sort of outweighing some of the downsides.
I'll look out for you after the session.
Please do. In terms of what are we doing in shipping, you mentioned the IBM Maersk project that's going on. It even has a name. It's called TradeLens now. And it is on pilot stage. So most people believe it's live and it's all there. It's on pilot stage. Just remember that. At Accenture, we also have built a consortium looking at pretty much the same thing. What IBM and Maersk is doing is trying to simplify the documentation process. What they are simplified set doing, they PDF all these 20 to 30 documents I talked about. They use the blockchain to exchange them in a secure way. Great, you get a much more secure exchange of documents. At Accenture, we have built a consortium with ourselves, of course, just to start with us. AB InBev as a shipper, Kühne & Nagel, a freight forwarder, APL, and now we also have Hapag-Lloyd on board and a European Customs Office. What we're doing in this consortium is that we are basically dematerializing all this document. So instead of using the existing document, we are trying to rethink how could we do this in a smarter way, taking full advantage of a shared platform. So we are not talking about putting documents on a blockchain. We put data fields. So we say what's interesting is not the document, it's not the bill of lading, it's not the letter of credit, it is the information that's there. And every single piece of data, so the place of origin or the place of destination is being determined by one party. We put that data field on the blockchain, that one party can update it and everybody else can see it. In that way, we are eliminating all the repeat work that you have when you're copying through the 20 to 30 documents. So what we have shown in our proof of concept is that we can eliminate 80% of the work, and we, of course, improve the accuracy significantly. We are planning to launch our pilot platform spring 2019. We believe that it's the most provocative and the most exciting project that's actually ongoing in the industry. Unfortunately, we're not quite as good at marketing as IBM and Maersk are. And that might be what breaks and makes whoever is winning here. So that's two different approaches, and only time will show which one is going to win. Maybe it's a completely third party.
I'll just respond briefly, and I'm happy to talk to you afterwards. So Enrupt is really a toddler startup. We've started in December last year with the idea to identify what the energy company of the future will look like. And mind that I'm talking about the energy company. I'm not talking about oil and gas company. I'm not talking about the utility. The thinking is to see what we are converging towards. Not only that, what will be the energy mix of the company, but what are the technologies that such an energy company of the future will use. And we do that in a very simple way. On one hand, we are a bit a marketplace at the end, I'm thinking, right? Because we syndicate startups. We build a database of startup solutions that are developed outside of the big corporations, and then we identified what are some of the problem statements, what are some of the issues that the big companies are facing, and how do the startups fit in. We come in at a time when the startups have a solution that is ready for deployment, and then we build activities and programs that allow the startups to deploy them within corporations. We currently, for full disclosure, run a startup program for Shell Singapore, for example, but personally, as a founder, I believe that there is, where the real added value is in programs that bring companies across the value chain. So my dream is to build a program where there would be a utility, oil and gas company, an equipment manufacturer working with a tech company, and maybe an Accenture type of consultant, right? Because I think that's where the real innovation will happen, is in collaboration. Next question.
I just want to ask about shipping, all right, because in the shipping world, it's so dynamic, all right, so what kind of blockchain will be applicable, will be the best kind, whether is it permissioned or public? Because, you know, we have changes along the way. From one end to the other, we can have maybe as many as 20, 30 parties, and it can change. These parties can all change, all right, and the problem with this is also that certain information from the start, you do not want certain people along the line to know, but when you come to the custom side, you may have to let them know everything. And the custom may not be that computer savvy either. They may want it to be in paper form. So given this kind of problem, what kind of blockchain would you recommend?
Well, first of all, Accenture is technology agnostic, so we can do everything. Now you ask about, and I guess this will be my personal opinion, I think for this kind of projects, a permission-based is what will have the easiest entry. And I think you're touching upon something really important, which is people's people need to feel safe. They're not going to get on board any kind of platform if they feel that they're being compromised with their data. And I think that feel about being compromised is becoming stronger and stronger. You also touched upon it, like now we can't do anything without somebody watching it. When you're talking about the customs, yes, they will have access, and that's exactly one of the reasons that we have emphasized to get a customs agent into our consortium. I think we are all still learning, and having 6 people, 5 parties in a consortium and agreeing on the governance structure, as I mentioned before, is exactly part of that whole thing. How do we do it in a way that everybody get what they need, everybody get what they want, and nobody gives away something they're not willing to give away? I don't think that's entirely solved. But I think the immediate answer is permission-based is going to be the winning part.
You see, I have a problem when I was thinking through it, is that you have a blockchain, and then all of a sudden, in the middle of it, you have to go into paper-based, because you've got to deal with the governments, you know, they don't want
True.
it to, yeah.
And,
so
and
how do you go into paper-based and then come back to blockchain again? And also in the, say for example, just BL, along the way you have cut BL, you have switched BL. How do you deal with all these issues? Do you recreate a new whole blockchain? Or is it possible to incorporate this into the one single blockchain itself?
I think that we're getting a bit into details, and I'll be happy to have a separate discussion. The end vision will be to have everybody on a platform or several platforms that are connecting, obviously. You're not going to get from 0 to the end vision in one go. So obviously you will have broken, you could say broken value chains. If you're thinking of a platform where you have all the data elements, it doesn't take a lot of effort to pull out a print, you could say. You could make it basically export the information, put it into a bill of lading, have that passed on, and then you would of course have somebody to replace it back into the blockchain.
But this is where you lose your integrity, isn't it? When you move from blockchain,
Absolutely.
So we will
go back.
Absolutely.
Why don't you get together after? Maybe you can invite Pernille for a drink. So we have still few questions. Fantastic. Who has question for Nicolas? There we go. Winner.
Hi, actually I have a question for anyone. You mentioned during the talk, all of you mentioned that there's new energy players coming in, small, medium, and they all bring energy, let's say in renewable sources, you were mentioning, I think. What I understand, I don't know much of energy, but I understand that the big providers, it's not that they flick a switch and energy is produced, it actually takes a long while of days and months to set up a plant that's producing energy at a big scale. And how is that going to gel with new, more agile off and on. Let's say it's a very sunny day, lots of energy produced, then next day it's raining, not so much energy produced. This is maybe not a blockchain question, but how does the ecosystem deals with people who can produce a lot and then a lot less energy, and the big producers who are more steady, always the same amount? How does that go together?
Do you want to give it a go from your perspective?
But yeah, so I think there's the way country works, because often it's managed at the country. First, they do a capacity planning. So they say, okay, so economic growth, demography, evolution, and then they anticipate on the need in terms of energy for the years to come. And based on that, they drive investment strategy and infrastructure strategy to motivate people to build capacity to answer these needs. And some countries are very bad at it, okay? If you look in the region, a lot of countries are still suffering from a lack of infrastructure, a lot of capacity. Then the other question is this intradays, or it's almost this real-time flexibility. So this problem has been going on for years, so it's not a new problem. People say renewable introduce more volatility. Yeah, it's true, but it's not something we cannot solve. There is a number of countries in the world that has been running for a day or for several days or for several months only on renewable energy. So managing the volatility of the energy, and through intelligent system and automation, ensuring that the grid is still able to provide electricity in a secure way without blackout. Then there is always different strategy. Some people, are driving the priority based on price. So when there is a lot of demand for electricity, the price go up. And that's why people can build what we call peak power plants, that are gas plants that are going to produce electricity almost only for the few days where it's very expensive. But the electricity gets so expensive during these few days that you can pay back your plant, even if you use it only 20% of the time. It's called peak power plant. Okay. I hope that most of the country tomorrow will give priority to the renewable energy. So I think as a country, you should always give priority to the decarbonized energy first. And then you compensate with other source of energy. Okay, so we hope we will see that more and more. It will come more and more because decarbonized energy are getting cheaper. So they will be more competitive. they will be more competitive on the market in terms of cost. So they will be the first one to be taken up to produce the electricity. But you could also do it as a sign of goodwill or as an incentive to promote the decarbonized energy.
You are doing this. You are building incentives for people to trade, right? Because you are making things cheaper. You are making investments cheaper, yes. And generally, by having a marketplace, you are making the product, which is electricity, cheaper for people to use. What do you think?
Yeah, but so what you asked, right? Well, it seems like a simple question. It's actually incredibly complex. Yes. It's incredibly complex. Grid stability is the mandate of the grid operator. The premise is to make it as stable as possible. The problem with renewables, though, right? So like out of Europe, for example, correct me if I'm wrong, right? But there's issues with dispatchability. It's not easily dispatchable. So what's dispatchability? The ability to turn it on and turn it off. Right? With a generation plant, you can say, I want more power, ramp it up. Too much, curtail, ramp down. With renewables, because of regulation, though you can pull the plug, you can't. You can't easily reduce the amount of power from these assets that gets put into the grid. So that's a problem. So in places like Australia, for example, so Australia is a very deregulated market, about 30 years already wholly liberalized, right? So what you've seen here is this. The grid operator there has a problem with grid stability because there's no visibility at a granular level of how many households are generating and putting out how much power into the grid, say on a hot sunny day, in the middle of summer, for example, suddenly there's a surge, right? Grid operator's not prepared for it, and vice versa. If someone's hitting all the air conditioning at the same time, not part of the grid, this is a problem. Now, how do we apply technology to go deal with this? If you could pull and read that production at a granular level and report that amount of data on every single household generating power back to the grid operator, then they're able to manage. Then their data becomes far more granular, far more accurate, and they can project better and better. So that's how technology could help. But it's still a very complex problem. It's balances.
Maybe to go back to the technology, I give an example. So in France, we have a lot of islands, former colonies, and they are very complex territory to provide power to. So you will have the same problem in Indonesia or in Philippines. And of course, because it's sunny place, people install renewable. But renewable creates some problems for the local grid. So in the latest deployment, they have imposed this system to be able to forecast their production for the next day. So there is a little computer in every installation who provide a forecast for the next day of the production, and this is used by the microgrid to do its regulation. That exists. So this technology is available, is being deployed in this territory.
It's not a technology issue, it's an investment issue. It's an issue
Often.
of who will pay, right? I mean, we have today, talking about the future of energy, today we have most of the technologies, you know, the 80-20 rule, so probably we have 80% of the technologies that we will use. But do we have the adequate financial mechanisms and investments to make them happen? No, because this is a regulated sector. So it goes back to the government, it goes back to the regulations and laws, and we don't have a representative of government here, whether Singaporean or European, but actually when it comes to deployment of technologies in energy, it's the regulators in a way that are, you know, sort of sitting back because they are not creating for now frameworks that will allow companies such as Electrify to go faster. For good reasons, for security of supply, for making sure that the electricity here is on, right? I'm not questioning that, but it's just a fact. So, and that's why we go slow. That's why we have the 5 to 10 year frameworks. 2 more questions? Yeah, unless we want to sleep here. Yeah, one here, one there. One more, last question, third one. No one? Okay, so we'll take these 2, please.
My question is to Nicolas and Martin. Studying for solar renewals for a while. I understand in some countries, right, Germany for one and one South American country, they generated so much energy that they have to pay consumers to use it. All right, you know about this, huh? So locally in Singapore, I think you heard of IKEA being their solar panels, you know, and Singapore don't have people who build photovoltaic cells and then sell it to the national grid. But I think in countries, neighboring countries, they do that. Okay, they on a sunny day they have more than they do. All right, they probably do it on a daily basis and sell it to the national grid. Maybe Australia do that with their vast places of land. Okay, like you say, Nicolas, France, probably they're doing that also. All right, Germany is very solar-centric, I call it. All right, they want to utilize solar and do this. All right, in fact, there is a solar association in Singapore, the one and only, which you all might want to talk to, where they have bio energy, solar and wind. Okay, so they're very good at it. They encourage renewables to be used in Singapore. All right, but what blockchain can do this, all right, is to utilize all the electricity, come back to you, the OEM, all right, the EMC people, where the gentailers and the gencos can even use blockchain to bill the consumers on a half-hour basis. All right, and that would be super good. And I like your idea of smart IoT things. All right, I think Samsung Smart Things have been doing this, and Samsung is one of your how they call, better competitors. All right? Okay, but come back to energy thing. My question is, how do you all look into the competition of, or rather into the future of where blockchain can be more efficient in having these renewables and pass back savings to the customers?
So the first thing to address, the fact that some of these countries have so much power, they pay the end user to use them, or they get the power for free. That is also in part to do with the dispatchability problem. They don't turn it off. You get like Texas, for example. West Texas, I think, has wind generation. There's so much wind coming in off the Gulf of Mexico. I think hours of late night hours, for example, power is free, right through to morning. So this situation is necessary because if you don't consume that power, so a lot of people assume, like they listen to Elon Musk and they think, oh, we can store all this power, man, put it in batteries. It's not going to happen. Not at a grid scale. It doesn't. It's too expensive. We're not there yet. Technology's not there yet. So that power can't be stored. It has to be consumed. If it does not consume, it puts strain on the various nodes within the infrastructure. It wears down the hardware. So it must be used, it must be consumed. So that's why it does this. Because the alternative then is that the cost of maintaining all this gets borne by the grid operator. So instead of that, they'll pay you to consume it instead. So that's one. Now, the ability to make power cheaper because of all these trackings. Samsung is one company that makes smart home solutions. There are many, many of these companies. TEPCO, for example, there is a specific product. In fact, we were just discussing this morning. They've got a product released only in Japan, built by Sony, and they've got a license for distribution in Japan. Everywhere else outside of Japan, open season. So we're lobbying for us to be the guys who move it out there. And what this is, it's an IoT conduit. It forms the heart of a smart home solution, which fantastically, because it's been mooted before in Japan, that TEPCO should be the entity to monitor and report on the health of the aging population. Which is staggering. Why is a power company getting into this space, and why should they be looking into this? Because, like I said just now, if we know your power profile, know your consumption, I can tell your health. You haven't turned off the lights for the last 48 hours, something's wrong with you. You haven't turned on the TV, you haven't gone and had a shower, you haven't used your power, even though you're at home, something's wrong with you. We can gauge these things, and this is all passive, just by reading the data, as opposed to making you wear a wearable, and there's accelerometer, and so on and so forth. All I need to do is read your power, and I can tell more or less whether you're still alive or not, or whether you need help, right? So that's where all data comes in. So what we are trying to enact and move into is, by being more granular about reading this data, reporting this data, we put the power back into your hands. Can we make power cheaper for you? Potentially, yes. But, as you said, a lot of it relies on regulation. Now, in the Singapore context, you can sell power back to the grid. There are two mechanisms. You have solar panels, and there are many solar panel companies in Singapore. They're all called EPCs, Engineering, Procurement, and Construction. EPC companies can build solar panels for you on your rooftop, and you can sell power in two ways. One, you register with the EMC to be a market participant, and you sell power back to them. EMC pays you USEP, the wholesale price, the Uniform Singapore Electricity Price. But which sucks, it's tedious, you must go through paper and all that. The second way is a simplified credit treatment. You sign up with SP. SP becomes an aggregator, and they buy over your power, and they pay you. They offset against your power bill. So that is the central intermediary scheme. So there already are schemes like that in Singapore. They exist. What we're trying to do is make this even smoother, where instead of you getting settled when you make solar power, as I showed just now on the surplus, you get settled on the wholesale price, which is one, low, two, volatile. Remember, 30-minute market, price goes up and down like crazy, right? It's been reported in the papers the last few months, it's been going nuts. Instead of making just that lousy amount of money on a very volatile level, we look at stabilizing it, allowing you to make more on a flat line instead. That improves your ROI for your project, whether it's commercial or residential. And that's what a trading platform does. As you pointed out, key incentive here is who pays for it. But there are two ways that money can come in. One, through investment, the other way through revenue. If we can give you an economic incentive to do this, could we not proliferate the installation of these facilities? Potentially we could.
People will do anything if they are paid. Would you like to comment?
No, I think maybe will it make the energy cheaper? I think yes. I think the falling price of solar and wind is contributing to making the overall cost of energy cheaper. And we will see this trend going further. So overall, yeah, I think blockchain is bringing efficiency all along the value chain, so it helps to increase the productivities. And most of the productivity gain at the end are being transferred either to the customer or to the shareholder. So.
Yes, please. I'm sorry if holding you guys back. So example of this is very, very simple. We pay in Singapore right now, the prices are trending, I can't remember. Well, yeah, 20 plus cents, but that's on the whole, that's not even wholesale price, right? So our prices for power are relatively low. I think it's about 15 to 16 cents on USEP right now, if I'm not mistaken. That's Singapore cents. In developing countries, right, in places like Myanmar, in places like Tunisia and Africa, for example, people are paying up to 2 to 3 US per kilowatt hour. And your microgrids, mind you, the only reason why they're not sitting in the dark, starving to death or whatever, is because they actually don't consume that much power. But per kilowatt, they're paying a staggering amount. So the question here is, can blockchain bring down the price of energy in our context or in their context? We can impact their context very much quicker. So the case use is this. We were approached by one of TEPCO's partners. This is another consortium. They've got trading deals going on with Myanmar. Myanmar, 70% of the population lives off-grid. So what happens here is this, they're already supplying fuel and hardware for power generation and so on and so forth. A lot of small little businessmen in there who have deals with the municipality, and they provide power and they charge what they want to charge, the tariff that they want to charge, right? So the question that this company asked us was this, can we impact this at all? And we said, well, no, we're not really interested. This is microgrid stuff. We don't really want to do it. But they were insistent, and TEPCO was involved. So we came back and we said, here's an idea. What if we could connect multiple microgrids up into a larger network instead? Would that make sense to you? Now, the problem, like I said, is not connecting people up physically. That's not a big deal. We know how to do it, right? The big deal really was, how do you settle, and why is that important? So imagine this, if there was one town or one village near a river with a good gradient, good flow rate, potentially they could have a hydroelectric power plant, a micro plant over there. But if they're the only ones consuming it, doesn't make sense. Who the heck cares about one small town? The ROI is not there. No one's going to invest. No one's going to build it. But if we could connect the multiple microgrids up, if they had a surplus and could sell that power to the next town over the hill, suddenly it makes sense. The ROI changes. That's what we were looking at developing, and that's the scoping of that kind of project. So can blockchain help? Heck, yes. Because if there was no technology layer like this, the cost to track, the cost to manage, the cost to serve this kind of a project is prohibitive. As the Hokkien say, 根本咪做, right? Might as well not do it. So this is where technology can help.
The last quick question? Yeah, I'll try to make it a quicker question. Thank you so much. The panel was great. It was very informative. My question is actually related to costs. So blockchain itself has costs, right? So how does that factor into generation of energy? And for power generators and for people who are building power plants, will that really bring up their costs if they're going to factor in blockchain? And does, maybe more question for either Martin or Nicolas, does it work, have you been working with, say, rooftop solar producers who are generating, who are building power plants and selling to commercial industrial customers? So yeah, kind of associated two questions. Thank you.
That's our customer. Project developer who install solar rooftop for commercial and industrial building are typically our customer. Mainly for large application, few hundred kilowatt or megawatt. So yes, we work with these people. Then for I'm not sure blockchain will reduce the cost of the power plants, but if you look at the cost of a project, I'll give you an example. For the small project, the soft costs represent 60% of the cost of the project. That means 40% is the solar panel, the inverter, the pole, the contractor, all the hardware that you buy. The rest is legal, finance costs, contractual work, the design. Okay. So it's quite impressive. And the good news is that on the hardware side, if you build a small asset or a very big one, you almost have the same costs because it's a very commoditized market. So if you buy for 200 kilowatt application or somebody who buy for 100 megawatt, you almost get the same price, really. It's a very efficient market. But where the project gets much more expensive is on this additional cost linked to the design, to the legal, the financial fee, everything around. And that's the part we try to tackle. That's the part we try to reduce. That's the part we want to lower. Because we believe there is an opportunity to reduce the cost for the end customer and for the people and making this project cheaper. So, yes.
Last one before we close is the matter of cost. I think I'll just address that. You can't believe everything you read, right? On social media, I see a lot of these things about how, wow, no, Bitcoin mining uses so much power, blah, blah, blah. Ethereum uses so much power. Has anyone ever stopped to ask how much power does a banking system use? How much power does any other system use? In the order of the magnitude of hundreds and thousands more times of what this technology does. And that's the thing. It's a matter of perspective. What exactly is the value that we're delivering for this energy that we're consuming, right? I think that's the key. In terms of cost, can be managed and can be adjusted. It depends on the design of the blockchain itself. It depends on the design of the protocols, how validation's done, how authorization's done, and so on and so forth. So there are many, many ways to do this, to reduce costs. And that's the answer, essentially.
Pernille, any last words before we close? Last words of wisdom? Okay, call for action. So, thank you very much. Thanks for the questions. Thanks for coming, staying all the way until the end. Please come and join us. The next event will be on 15th of November. We will be talking about connected customers. The event will be held in iProspect in the city center. And we'll have, again, few startups, industry people talking about, customers. We never talk about energy customers, so this will be a dedicated discussion about that. I want to thank our speakers because they've taken their time instead of going home having a beer, so I really appreciate that. And we are still looking for that beer sponsor, by the way. I'm always repeating it and they never come, so please. But thanks, Martin, thanks, Pernille and Nicolas. It was great discussion.
Thank you, Katarina.
Yeah.